Good morning. This is Mrs. Doris. It is Thursday, November 6th, and this is warm-up number 3. The first problem is a review of yesterday's lesson, and problem number 2 is preparing us for the AMC8 contest, which is scheduled for November 18th. And this is a timed test. It's a contest, and we'll send in everything, and they will send us the results. So we're going to add to our warm-ups just a problem to help get ready for it. Um, I'm pause the video right now and work on the warm-up. If you have any questions about it, then please ask me. All right. Lesson 5.3 is our lesson today. It's on slope-intercept form. This is the most common type of linear equation. It's a most useful type of linear equation, and it's one of 3 forms that we will be learning in this chapter. So our objective today is that you will write and graph linear equations in slope-intercept form. And throughout this whole chapter, we are learning about linear functions because they're very useful in solving real-world problems. Vocabulary. We have quite a number of vocabulary terms today. The first is family of functions. And a family of functions is a group of functions that have common characteristics. A parent function is the simplest function of a group with common characteristics. And the linear parent function is basically y equals x, or the function at x is equal to x. Remember, f of x is simply another name for y, but f of x is considered to be function form. The y-intercept is the intersection of a point where the line crosses the y-axis, or another way to look at it is it's the value of y when x is equal to 0. Slope-intercept form is a form of a linear equation of a non-vertical line which is in the form of y equals mx plus b. And this is a form that you should memorize, where m is the slope and b is the y-intercept. This is a diagram I'd like for you to draw into your notes. Note the m, which is an unusual variable to use for slope, but it is the one that mathematicians use. And that is shown in blue, all right, and it is always the coefficient of the x term. Remember from our lesson previously that slope is the rate of change as well. Anything that is added to it is your y-intercept. If you have minus b, then your y-intercept is negative. If it's plus b, then you're going to have a positive y-intercept. All right, so let's look at problem number 1. Identifying slope and y-intercept. What are the slope and the y-intercept of the graph of y equals 2x minus 3? All right, I'm going to rewrite this equation as an addition sentence. So 2x minus 3 is the same as 2x plus negative 3. All right, so we should easily be able to identify our slope is always the coefficient of the x, so the slope would be 2, and the y-intercept is what is added onto it. So in this case, it's negative 3. If you look at the original equation, just note that you have to take the operation with the number. So minus 3 is the same as adding negative 3. All right, now let's graph it. You want to start at the y-intercept. The y-intercept is going to be along the y-axis, and it's going to be at negative 3. So at negative 3 on the y-axis, there is your y-intercept. Now, next we're going to use the slope to plot more points on the line. So the slope is 2, and 2 can be written as 2 over 1. So therefore, we have a rise of 2 and a run of 1. So starting from our y-intercept, we're going to go a rise of 2 and a run of 1. And there's another point. Rise of 2, run of 1. There's another point. Rise of 2, run of 1. Rise of 2, run of 1. And in fact, you can even go, you kind of see the stair step, how it works. You can even go the opposite direction. You can go minus 2 over minus 1, because we all know that that is the same as positive 2. So you can go down 2 and left 1 and plot more points. And let's draw the line now connecting these points. All right, and that's what our line looks like. And be sure that you add your arrows at each end to show that the pattern does continue. Now, the really cool thing about the slope-intercept form is the fact that we've graphed the line without making a table. But real quickly, I want to show you why it works. If I were to make a table for y equals, and I'm going to write it again down here, y equals 2x minus 3. If I were to substitute 0 in for the x, 2 times 0 is 0, minus 3 would be equal to negative 3. And notice in the vocabulary, the definition that we gave for y-intercept is one of the definitions. It's the value of y when x is equal to 0. So there is our y-intercept. If I put in 1, I would have 2 times 1 is 2, minus 3 would be equal to negative 1. So at 1, my y value is negative 1. And notice right here is that point. All right. Likewise, if I put in, let's say 4. All right. I'm going to substitute 4 for my x. 2 times 4 would be 8. Minus the 3 is equal to 5. So at 4, 5, I should have a point. And notice, please, on our graph that at 4, 5, we have a point as well. And you will find that every point on this line, including everything in between these points on the line, will satisfy this equation and make true statements. So the nice part about our slope-intercept form is we're able to graph without even making a table and doing a lot of computation. All right, problem number 2. Writing an equation in slope-intercept form. What is an equation of the line with 1/2 slope and a y-intercept of negative 5? All right, well, let's go back to our form, y equals mx plus b. M represents our slope, so our equation, we're going to put the 1/2 in for the m times the x, and then our y-intercept is -5, so I'm simply going to write -5. And there is our equation. Now, let's graph it. We always start at the y-intercept of -5. So on the y-axis, down here at -5 is where I'm going to start. My slope is 1/2, which means that I have a rise of 1 and a run of 2. So I'm going to rise 1 and run 2. And there I would have another point. Rise 1 and run 2. And there's another point. Rise 1 and run 2. And there's another point. And you can see my line is going to be practically off the grid, but it is in the lower quadrants. Okay, it will eventually get up to quadrant 1 if we extended our graph out far enough. All right, problem 3, writing an equation from a graph. What is the equation of the line shown at right? Now this is another nifty thing about slope-intercept. We can look at a line and write the equation. So what we do need to identify are points on this line where the line goes through the y-axis, first of all, and it looks like that we have a slope of 2. And we need to identify what our rise and run is. I'm sorry, hang on, let me go back. It's early morning. Our y-intercept, b, is +2. Now, let's look at our rise and run. This appears to go through these points right here. Okay, and my line may be a little off, but that's what I intended. So let's identify what our rise and run is. First of all, it's going downhill from left to right, so we know we're going to have a negative number. My slope, my rise, I'm going to go from the top point to the next point, would be down 1, which is -1, and to the right 1, which would be a +1. So what I have is -1 over +1, and that is simply equal to -1. So I've identified my slope and I've identified my y-intercept. So now in my slope-intercept form, y equals mx plus b, which you need to remember, all I have to do is substitute in my slope, -1 for the m, and +2 for the b. Your book will write this as -1x is simply -x plus 2. Always remember that a +1 doesn't need to be shown at all. A -1 can simply be shown as negative. So -x plus 2 equals y. All right, problem 4. What equation in slope-intercept form represents the line that passes through the points 3, -2 and 1, -3? All right, so step 1 is to use the 2 points to find the slope. So here we go back on step 1 to our slope formula. Our slope, and we'll use m to represent the slope, is the change in our y values, which would be -2 minus -3. Remember, it doesn't matter which one comes first. But since I started with -2, I now have to start with the 3. So I'll take 3 minus 1 as my change in x in the denominator. Solving, Negative 2, let's add the opposite. Negative 2 plus 3 would be 1. 3 minus 1 is 2. So my slope is 1/2. All right, that's step 1. Step 2, we're going to use the slope and the coordinates of one point to find the y-intercept. All right, so here you have a choice, and I'm going to actually do both, just to show you that it doesn't matter which point you pick. First of all, I'm going to pick 3, negative 2. All right, so we're going to go to our y equals mx plus b form, and we're going to start substituting in some values. Here, my y in this point is negative 2, so I'm going to substitute in negative 2. My slope goes in for the m, so 1/2. My x coordinate is 3, so I'm going to substitute in the 3 and add b. Now, in this case, we are solving for b in order to find the y-intercept. So I have negative 2. 1/2 times 3 is 1.5 plus b. To isolate the b, I need to subtract 1.5. And if you want to change that to a decimal, you can. And so that gives me b on the right side equals negative 2 minus 1.5 would be negative 3.5. All right, so I now have my slope, 1/2, and my y-intercept, negative 3.5, and I'm now ready to write slope-intercept form. So going back again, I'm going to show the original model of slope-intercept. All I have to do is substitute in. I'm going to go back to my variables, x and y, and my m, my slope is 1/2 that we found in step 1, and my y-intercept b is negative 3 and 1/2. So here is my equation of the line that goes through the 2 points up above. Now, just to show you that it doesn't matter which point I pick, I'm going to do the same thing and with 1, negative 3, and show you that we're going to get exactly the same equation. So, using my y equals mx plus b form, I'm going to substitute in negative 3 for my y. My slope is 1/2. My x here is 1. And then I want to look for my y-intercept. And if I get negative 3.5, then we have the same equation, and I've proved to you that it doesn't matter which point you pick. All right, so I have negative 3 equals 1/2 times 1 is simply 1/2. All right, then subtracting 1/2 from each side. My 1/2 minus 1/2 is equal to 0, and 0 plus b is equal to b. On the left side, negative 3 minus 1/2 is negative 3.5. So I get the same y-intercept, and substituting in, we have the same equation. So you don't have to use both points, but you can pick either point that you wish. All right, problem 5, graphing a linear equation. What is the graph of each linear equation? All right, and down below you see the instructions. Plot the y-intercept first, and then use slope to locate other points on the line. We've already done this in the lesson, but it's a great idea to do it just a couple more times so that you feel comfortable with it. All right, in our first equation, I'm going to start at my y-intercept. So on the y-axis at 4, I'm going to plot my very first point. My slope is negative 3. Negative 3 can be written as negative 3 over 1. So I have a rise of negative 3, which would be a downward direction, and a run of 1. So right here I have another point. Down 3 to the right 1, another point. Down 3 to the right 1, there's another point. So my line is going to look like that. All right, and I'm showing the stair step, my rise and run, on the board. On your paper with your pencil, you don't have to draw the rise and run, but you can just use your pencil to move that many spaces in order to plot your next point. All right, let's do one more. Here in this equation, our y-intercept is negative 3. And our slope is 1/2. So I'm going to demonstrate what I mean. You won't be able to see my pen move, but hopefully you can follow the rise of 1 and the run of 2. So I'm going to go up 1 and over 2, up 1 and over 2, up 1 and over 2. And you can even extend this now in the opposite direction. So that you have lots of nice points to make your lines straight. And this is one place I would definitely use quadrille paper, graph paper, and I would use a ruler if you have trouble with drawing straight lines because you want your graphs to be as accurate as possible. All right, problem 6. This is a real-world type problem, and this is going to be a modeling a function. A plumber charges a $65 fee for a repair plus $35 an hour. Write an equation to model the total cost Y of a repair that takes X hours. What graph models the total cost? All right, so let's get ready. Our total cost is our Y, and I'm going to write our model of slope-intercept up here, and the X represents the number of hours. All right, so our equation, we are told that there is a $65 fee plus $35 per hour. The $35 per hour I'm going to write first, and that can be represented by 35 times X, which is the number of hours. Then the $65 fee is added on. All right, so let's go to our graph. And we're going to determine a scale that we can use. All right, so Y represents the total cost. And if I had room to write a title, I might title it plumbing cost. I'll go ahead and do that. All right, every graph should have a title. And then across the bottom would be our hours. Okay, so I believe on the bottom, I just want to go by ones. So 1, 2, 3. I'm going to start skipping because it's hard to make these numbers very small on the grid. So notice every line represents 1. All right. Now for a scale for our total cost, we have a y-intercept of 65, and then it's going to go up from there. So I think what I want to do is make every line worth 20. So 20, 40, 60, 80, 100 would be right here. 20, 40, 60, 80, 200 would be right here. And 20, 40, 60, 80, 300 would be at the top of our graph. And we'll see how far we're able to get with our graph. Now, we know that we're going to start at the y-intercept of 65. So let's see, 20, 40, 60. 65 is going to be right above the 60 line. And then we're going to go up 35 at a time. And it is helpful, especially when you're dealing with big numbers like this, to go ahead and make a quick table. We'll make our graph much more accurate that way. If we had a large enough sheet of paper that we could go by ones, we could just count. But here we go. All right, I'll go ahead and show 0, 65 because that is our y-intercept. If I put 1 in for x, 35 times 1 gives me 35, plus 65 is 100. So let's plot that point on our graph, 100. Okay, let's plot 2 points. Okay, if I put 2 in for my x, 35 times 2 is 70. 70 plus 65 would be 135. And so at 2, this would be 120, 140, so it's going to be just below the 140 line. And you can see we can probably guesstimate some of the rest of our points as we go, or you can extend the table, but the graph is basically going to continue going in a straight direction that way. Now, this is one case on a real-world problem that we don't put an arrow on the left end simply because it does not make sense to have a negative number of hours. So that is why we start at the y-intercept and then it will continue on in the other direction. All right, that is it. Your assignment today is page 312 and 313. I'd like you to do 7 through 35 and the odds and number 45. Okay, you may wish to have graph paper for this. It will make your drawings much more accurate, and I do require you to be precise with your drawings. So please use graph paper. And try this before you check your answers in the back. If you have any questions, bring those to class tomorrow. Thank you.